Hello everyone. Our today's question is K radius subarray average. So let's understand the problem statement and then we'll see the approach and coding part. So what we need to do in this problem, we have given one array and along with this array we have given this K value that is 3 here. So what we have to do, we have to find the average for elements who has K radius. So K radius means the element, if the element has K elements in the left and K elements in the right, so this K element, like this area, like this complete area is the radius, like this lies in the radius of this element, like three elements in the left and three elements in the right. So this is the radius for this element. So what you need to do actually, you need to find the average for this element, like this complete like for this complete area you need to find the average and you need to put that average on this index. And similarly you will do for this, like for this means three elements, we will see like three elements are these in the left and three elements are right in the right are these elements. So for these many you need to find the average and put it here. So similarly we will do for every index, for every element we will see, like if it has the k radius means k in the left and k in the right, then find the average and just put it in the new array and just return it. So why this minus one, like obvious, if you are here, let me rub this so you can understand it properly. So why minus one? So I was telling minus one because from this index you can see k elements in the right, but you cannot see but you don't have k elements in the left. And for finding the average it is necessary you should have k radius. K radius means k elements you should have in the left and k elements you should have in the right also. If you don't have, if you don't fulfill the requirement, you will just put minus one for that index. So for only these these index 3 4 5 you can see k radius, but from this again on this index 6 you don't have three elements in the right, so you are again putting minus one from here onwards. That's why. So let's see how we can approach this problem. So I will be talking about two approaches. First one is your brute force approach, and then we'll see optimize approach. So in optimize we'll discuss the sliding window approach. So let's see how we can approach this problem with brute force technique. So it is clear that for finding, like you need to find the average for which element where you have k radius. So just check uh, the, like you start the traversal from here, like from this zeroth index you will start the traversal. You will put a loop here from this zero, and you will check, do I like am I fulfilling the requirement? Do I have k elements in the left and k elements in the right? This will say no, I don't have. So just put it forward. You will come to this index. So do I have k radius? No, I cannot see three elements on the left. So move forward. Okay, I have come to the second index. I'm saying no, you don't have k radius. Then I'm coming to this. Do I have k radius? I say yes, you have three elements in the right and three elements in the left. So I will say yes. This is the time when you can actually find the average. So what I will do, I will find the average. Average for what? For I will just add this element along with these three in the left and three in the right, and after calculating the average I will put the value in a new vector or an array and I will just return it. Like similar I have done for this index 3, I will do for index 4, index 5, and when I will come to 6 I will again check, is this element fulfilling the requirement, fulfilling the condition? If yes, then find the average. If not, just put it minus one. So this is your brute force approach. So what you are doing actually, in this brute force approach, you are going to every index and finding the k elements in the left and k elements in the right. So what will be the time complexity for this approach? So what will be the time complexity, guys? You are going to every index, so that is n. It will take n time. You are, because you are going to every index, and after going to every index, what you are doing, you are actually you're actually going to find k elements in the left and also in the right. So for every element you are doing this, because when you will go to this k index, then only you can find like you have k index, you have k values or not, or when you will find the average, that time you need to go to these k elements. So n into k for going to these elements that are lying in the radius. So the time complexity will be n cross k. So can I optimize this? Yes, the answer is yes. You can actually optimize this. How you can optimize? We will see the sliding window approach to optimize this problem. And with sliding window, like let's see why sliding window first of all. Like how will this sliding window work? So the intuition behind using this sliding window is you are seeing like from this index 3 the condition is valid. Like from this index 3 onwards uh, you can actually find the k radius. So let's treat this as a window, right? Let's treat this as window. This is your first window, and when you will move, like you are on this third index, so when you will move to this fourth index, you what you are doing, like for index 4 this will be your window, right? Like if you are index 4, so these three 1 2 and 3 index in the left and 5 6 7 index in the right. Fine. When I will move to this 5, I will have elements from this second index, like from this second to this 8th index. I will have these many elements. So can you observe something? Can you observe this every time? Like when, like this was my first window. This is my first window. So when I move to the second window, I am actually discarding this old element and I am adding this new element, right? And when I again move to this index 2, what I'm doing, I am again discarding this old element and I'm adding this new element. So I'm getting the vibe that once I have made this window, once this window is made, what you are doing, you are just adding one new element like this and you are discarding this old element. So this is the intuition behind using sliding window approach. So what you will do in the sliding window approach is like exact same thing. You will first of all uh, configure your sliding window. By configuring means like make this like the size is k, so we will make 2k plus 1 size of window in the initial stage. So initial configuration, that is our initial configuration of sliding window, like make the k size window, that's what I mean. And you will then slide the window. Slide the window means just add new element, right? Just add new element and discard old, just discard it, you don't need that. And when like while you are sliding the window, that time you need to find the average and store that average in the answer vector or answer array. So this is you need to do. So what will be the time complexity for the sliding window approach? So what you are doing, you are making this uh, 2k plus 1 size window. Like once you have made this window, you are just sliding it from the starting point to the ending point, so you are just traveling n elements only this time. So the time complexity will be order of n. So this is now reduced to order of n. And let's see the code now. So what we are doing, let me extract the code. Yeah, it came. So what I was saying, like this is a first step to start with sliding window. Like this is sum is for what, like when you are making the window. So let's like summing up the initial stage elements of sliding window. And this window size is what, like 2 into k, like 2k elements will be there for in every window. Like the size will be 2k plus 1, but the radius will be 2k, like k in the left and k in the right. This is for that. I will explain like why we are needing this. Then making a vector to store the averages, and then we are just sliding the window. Like after making the window, just slide it. So what we are doing, we are summing up the values till uh, till initial configuration, and once the I index has reached to 2k. Like 2k means what? Once once like you have made this you have made this initial configuration, like 2k is what, 6, the value is 3, so 2k is what, 6. So after coming to this 6, you can actually calculate the average, right? Because you need k in the left and k in the right. So once you have reached to this 2k, then you can actually find the average. So just store the average at answer of k means this index 3. You can store the averages here. And like how you will find the average, like sum upon the total elements. So what are the total elements? The window size, like the 2k plus 1, 2k because left k in the left and k in the right, and plus 1 is for the current element. So just store the average on that index and discard the old element. So I am discarding the old element. How? Like this j is in the starting, so every time this window will move, this j will point to the next. So like when this window will move, so I will discard this zeroth element. So now the elements will be from this to this. So that's why I'm discarding the elements from this step, and every time I'm adding the new elements in the window. And in the last, I will just return this answer vector that has average for elements who has k radius. So I hope you have understood. So if you have understood, please like this video. If you have any doubt, you can ask that in the comments. And if you are new, so let me tell you this. I upload video solutions for DSA problems, and where I explain everything like this problem: approach, intuition, time complexity, code as well. So if you like my explanations, you can subscribe to the channel. Thank you.